Okay, let's begin with series. Series, adding up a sequence of numbers. That's what a series is all about. It's a sum of the terms of a sequence. Okay, they have a tradition and they have a notation for it. They use a capital S in Greek. This is a Greek capital S. Going to be quizzed on this, just kidding. S, okay, and it stands for sum. Okay, all right, and so we're going to break this into two videos if the technology works for us. We're going to talk about notation, and we're going to go through the divergence test, and then the second half will be these new series for us. Okay, so first of all, there's notation that's going to look very similar, very familiar, because we already talked about the sequence notation, and this is very similar. Whenever you see this particular symbol, that means you're summing up stuff. What are you summing up? Well, there's a formula for all those guys. Okay, so what you want to do is you want to look at the notation. Oh, look, it starts at 1 and it goes as far as you want to go. So you start going like, okay, this is the sum of terms. And to figure out the terms, you just plug in n is equal to 1, apparently, and then 2, and then 3. Okay, so when you plug in n is 1, you get, we've seen these numbers before, but we'll write them again. 2 times 1 plus 1 over 3 times 1 plus 4. 2 times 2 plus 1 over 3 times 2 plus 4, and one more. 2 times 3 plus 1 all over 3 times 3 plus 4. And of course, what we're getting is the same numbers as the previous lecture. We have 3 over 7, 5 over 10. What else we have? We have 7 over 13. And as I recall, if you keep going, 9 over 16. If you go any farther, maybe 11 over, what is that, 19? But the thing about this is you string the numbers out, but what's happening is you are adding them together. And you can add as many as you want. Okay, depends. Depends on the homework, really. In this case over here, we've seen this guy as well. It's going to be starting at 1 to infinity again. Sometimes it starts at 0. Sometimes it might start at 2 or 3. But in this case, the same thing. We're going to be adding up terms out here at infinity. So in this case, when we've seen these guys before too, I did it on purpose. When n is equal to 1, we get minus 1 to the 1 over 1 plus 1 factorial. Minus 1 to the 2 over 2 plus 1 factorial. And minus 1 to the 3 over 3 plus 1 factorial. And I remember seeing this guy, it looks something like, well, we've got a negative 1 over 2, but then we have a positive 1 over 3 factorial. Negative 1 over 4 factorial, positive 1 over 5 factorial, negative 1 over 6 factorial, and you just go as far as you want to go. The reason I went out 5 is, well, look, my problem will say something like this. Why don't you find the first 5 terms of each series? Well, I could say for problem number 1, we're done. We found the first 5 terms of the series. And in this case, we can clean it up a little. It's minus 1 over 2 plus 1 over 6 minus, use your factorial button, or the next one multiply by 4, and then multiply by 5, and then multiply minus plus minus plus minus, multiply by 1 over by 6, and you're getting something like this. Okay? All right. So those are the first 5 terms of the series, which is the same as the first 5 terms of the sequence, except instead of commas, we put pluses. Now here comes something interesting you want to pay attention to. We're going to talk about the sequence of partial sums for each series. The sequence of partial sums. So here's the thing. We want to now spend a few sections on whether a series converges to a limit or diverges. How the heck does it converge to a limit? What do you do? It's a good question. What you do is you look at the, how are we going to scroll this thing? Okay. I think I'm having a little bit of trouble with this guy in order to scroll him. So he's not behaving. Oh, there you are. Okay, cool. So we'll keep working here. I'm going to have to deal with this faulty Microsoft Word for some reason, just not letting me do that. There we go. I'll just use, okay, it's weird. Okay. So in order to figure this stuff out, it would make sense to, let me repair this. It would make sense to just add numbers and add numbers and add numbers and see where they go. Okay. So I went to the, well, what happens is you talk about the sequence of partial sums. Okay. And that's what it means by adding numbers and adding numbers. So let's talk about this guy. The first number is 3 over 7. But then if we add a number to it, the next term is 5 over 10. And if we keep adding like that, where are you here? Let's see. Okay. This is going to be weird on this one. Okay, 3 over 7 plus 5 over 10 plus 7 over 13. You get the gist of it. 3 over 7, 5 over 10, 7 over 13. How about 9 over 16 and 3 over 7? What I'm doing is I'm taking snapshots of these particular sums, this particular sum. So we've got 11 over 19. They have a name for these guys, and I'm going to write it in. The first guy is S sub 1. That's the first partial sum. Do you get the idea of the word partial? It means you didn't sum up all of them, because to sum up all of them, you'd have to go to infinity. But we will say, hey, that's the second partial sum. Here's the third. Get it? You're going to add the first 3. The fourth is the first 4. The fifth partial sum is the first 5. I went to the liberty, well, of course, of calculating these to make this video a little quicker. And I got, for this one, of course, 3 divided by 7 is roughly 0.43 and stuff. The next one is 0.928. I think I have that right. 0.928. The third one is 1.467, 1.467. The next one is 2.03 roughly, 2.03. And the next one is 2.608, 2.608. Okay. Now remember, in the previous time, we looked at these terms and we said the sequence of numbers goes towards, I think we said, let's look. See it right there? 2/3. So every time I add, we got some number that's closer to 2/3. And the question becomes, let's see where we are. Sorry. Where do these sequences, where does the sequence of partial sums go? Because if you could tell where this was going, you could figure out, if you could figure out that limit, you would have the sum. And that's an important part. The sum of the series, if you could do it at infinity, is equal to the lim, as n goes to infinity, of the sequence of partial sums, if it exists. Okay, I think on this I had instructions to go find the first 5. Okay, we did that. Please note the difference. So I'm going to now work on the next one. Let's work on the next one together. Where are you? There you are. In this case, I don't know if we want to write all this stuff, but we're going to go S1, S2, S3, S4, different sequence, right? S5. And we're looking at the sequence of partial sums. And in this case, it starts out minus 1/2. Well, so do all of them, don't they? But then the next one says add a 6th. Okay. 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 You don't have to write all this stuff. Subtract 1/24. Okay. See what I'm doing? On the fourth one, add a 1/120. And then finally, out down here, minus 1 over 720. And of course, yours truly went to the trouble with a calculator to speed things up a little bit. And for these guys, I got, of course, up here, negative 0.5. Okay, that's the first term in the sequence. And the next one is negative 0.3, and it just repeats. The next one is perfectly negative 0.375. That's hard to read, so 375. Okay. Have an extra negative too, huh? Okay. All right, and the next one was a negative 0.36 bar. And then finally, this last one was a negative 0.368, negative 0.368. Okay, so if it has a limit, okay, if it has a limit, then you're going to look at the sequence of partial sums to see where they go. And what I have in the homework here, or at least, oops, what happened there? Come back. Okay. Oh boy, it's freaking out on me a little bit. I think it's worn out. Okay, what I have in the instructions is just, take a look at the difference between these two. Do you think they converge or diverge? And right now, with what I've given you, I don't think we have enough information to tell. What I do know, though, is I have a feeling that this guy, if you keep adding 2/3, it might go to infinity, in which case we might say it diverges. We don't know. That's the homework in the future sections, is to run tests to see whether it converges or diverges. This one seems to be camped out and kind of not going anywhere. It seems to be bouncing back and forth. We call it an alternating series, by the way. And it might go to, I couldn't tell you where it goes, but I think it might converge. And that's kind of the conversation we might want to have. The sequence of partial sums tells us whether it converges or not. Okay, if the sequence goes to a limit, we know the sum goes to that limit, and that's it. A lot of times in the homework, we can't even tell you what the limit is, but we can run some tests. Okay, here's our first test, and it has to do with the first one we did here. Okay, this is a good one. It's called the divergence test. All right, it says our first test on convergence and divergence, and here's what it says. This is kind of interesting. I got to do this to make a move. Basically this, you got a series, and it says if the terms of the series do not go to 0, then the series does not converge. Okay, if the terms of the series do not go to 0, then the series does not converge. Anytime you're looking at, I'll make one up. Anytime you're looking at one and they go, hey man, this is the instructions for the next few sections. Determine if the series converges or diverges. Here's what this test looks like. I'm going to run the divergence test. That's one of the things I want you to do, is state the test you're using. I'm going to take a sub n, which is in this series, it's 2n plus 1 over 3n plus 4. Let's go off to the side. Series typically, in general, they use this notation. Remember, for a sequence, they would say a sub n equals or b sub n equals. Well, for a series, they go series a sub n equals or series b sub n equals. And so what I did is I detached this definition of the n terms from the sigma notation, and that's what's happening here. Again, if the terms, that is to say, if the limit of a sub n is not 0, it diverges. Okay? So I'm going to take that out, and I'm going to run the test. I'm going to go lim, as n goes to infinity, of the terms is lim. N goes to infinity, in our case, 2n plus 1 over 3n plus 4. Well, we know that limit. The limit is 2/3. And guess what? It's not 0. That implies the series... Well, actually, what I had to do, I'll write it out. Series 2n plus 1 over 3n plus 4 diverges. Okay, and that's the big thing. It diverges. All right. Here's the story. If you are adding numbers that eventually look really, after a while, 2/3 roughly and 2/3 roughly. And you know what? You got an infinite number of 2/3. That means that, oops. That means that you're really going infinity times 2/3. I don't care. It's infinity. This sum goes off to Never Never Land. I'll say one more thing, and this is an important part of this test. Note, if the terms do go to 0, we do not know if the series converges or not. Okay? So what does that look like? Well, here's a series down here. Uh-oh, I did it again. Come back, little Sheba. Now it's not doing it at all. Okay, we're having trouble with Word, so I am going to stop this video.